Hello again, Unit 6, Lesson 5. We are going to be focusing on graphing square root and cube root functions. So, these are going to be examples of radical functions. And so we've dealt with radical functions by graphing the square root of x, the cubed root of x, stuff like that. And now we're going to, again, kind of put this into a standard form so that we can translate it vertically, horizontally, those types of things. So kind of our base functions, like that we're always going to compare things to, is y equals a square root x minus h plus k, and y equals a the cubed root, so we've got the 3 there, of x minus h plus k. So again, the important parts, you've got your a, you've got the minus h, and then you have the plus k on the bottom. So those are kind of going to be the differences. And then we have these things called parent functions. We've mentioned those in the past. So again, these are kind of functions that you kind of want to have like in your brain that you can access and compare other graphs to. So this is the parent function of a normal square root function. So just the square root of x. Notice though, down here, the domain and the range. We only stay in our positive x's and we only stay in our positive y's. So that's something that a square root function will never have negatives like that, unless we translate it or flip it or something. Whereas this cubed root function, so again, it's slightly different. The cubed root function has a range of all real numbers because it goes in this way forever and it goes down here forever. So again, these are called the parent functions. You want to get these like kind of etched into your brain so that you can access them. So if I were to try to graph a square root function, perhaps I wanted to graph y equals 1/2 square root x, and state the domain and the range, compare the graph with the graph of y equals the square root of x. Again, if I was going to do it by hand, I would make my x's and my y's, say 0, 1, 2, 3, and 4. And I would say, okay, if x is 0, y is going to be 0 as well. If x is 1, y is going to equal 1/2. If x is 2, y is 0.71. Again, I'd be using a calculator to get these numbers. And x is 4. So again, 1/2, the square root of 4. The square root of 4 is 2. So 1/2 times 2 gives me 1. So again, if you were graphing this, you might say something like, if this is my graph, 2, 3, 4, let's say we've got 1 right here, 2 up here. My graph is going to be, okay, so when x is 0, y is 0. When x is 1, y is 1/2. When x is 2, it's a little bit more. When x is 3, it's a little bit more. And then finally, when x is 4, y is 1. So this would be my graph of y equals 1/2 square root x. If I, again, were to draw the original parent function, I know that when x is 1, y is 1. So it'd be like right here. And it would be increasing like that. So that's one way that you can graph it by hand. Again, it's also helpful to use graphing calculators, those types of things. You have to find important values. So again, the important values that I kind of was looking at for these ones were these 3 for my y is 1/2 x, because I can clearly label when it's 1/2. I should get the correct color. This is 1/2. This was 0, and then this one was when x is 4, y was 1. Perhaps I wanted to graph a cubed function, so maybe I wanted to graph y equals -3 to the cubed root of x, and state the domain and range. So if I went back to this one, again, my domain is going to be, x has to be greater than or equal to 0, and my range, same deal. Range would be y. Okay, so looking at this next one, -3 to the cubed root of x, state the domain and range, and then compare to the graph y equals the cubed root of x. So again, I would just do like I did last time. I would kind of come up with a table of values. I'd say -2, -1, 0, 1, and 2. And then I would use my calculator to help me come up with the values: 3.78, 3, 0, -3, -3.78. So as I'm graphing this, -2, 0, 2. Woo. Sorry about that. Picture fell. X is -2, y is 3.78, x is -1, y is 3, x is 0, y is 0, x is 1, y is -3, x is 2, y is -3.78. So we can see our graph kind of going, oop, that's missed it there. Something like that. And again, this is y equals -3 cubed root of x. And if I were to draw my standard graph, again, my parent function tells me, all right, I know I'm going to be here, I'm going to be down here, and it's going to kind of increase like this. So that's my parent function. The domain and range are going to be all reals for both. Domain, this means all real numbers. Range, it's a fancy R. Okay. Again, just want to show you how you can use Desmos to help you with that. So if I were to open up Desmos, maybe I said, okay, -3, I wanted to do the cubed root. So I'm going to go to functions. Right there, we can type in the 3, plug in an x, and there's my function. If I wanted to compare it to the original function, which again was just the cubed root of x, we can see that we have it right here. And this is how you can kind of find different values. All right, keep going. So graphs of radical functions that we may transform. So again, step 1 is to sketch the graph of, so we have this form, y equals a x minus h plus k, or depending on if it's a cubed root function, y equals a cubed root x minus h. The x minus h is underneath the underneath the square root sign. So step 1 is graph y equals a sub x, or y equals the cube a to the cubed root of x. And then step 2, you're going to then apply the horizontal translation. So translate the graphs horizontally h units. And vertically k units. So for an example, okay, let's take the function y equals negative 2 parentheses x minus, or square root sine x minus 3 plus 2. First, I would just graph what negative 2x, what y equals negative 2x would look like. So I might say, again, I can make a table of values. I'm going to just show it on here. So y equals negative 2. What is it? Negative 2x. So that kind of looks something like this. So that's what, again, I'm going to compare kind of my parent function. The negative sign is why it flipped upside down. And then because I have this part right here, again, x minus 3. My base formula is x minus h. So when it is subtracting here, that means I need to move right 3 units and move up 2 units. So I would take this graph that I had, and again, if you want to plug in like a table of values, you can do that. Where's Desmos? There it is. And if I said, all right, well, I want to actually do negative 2 square root x minus 3, and then my final step is going to be to add 2. So that's what my new graph is going to look like. So if this is my original kind of function, and then my new one, the translated one, is going to start up here and go down here. So when I state the domain, my domain is not all the x values, because again, my x value right here is 3. Again, because I moved it to the right 3 units. So x is going to be greater than or equal to 3. My range, again, it's not all positive numbers. This is a 2 because I moved it up 2. So it's going to be all numbers that are less than or equal to 2. It's basically the same process for a cubed root function. So I'll just do one more of those. So let's say, all right, let's take the equation. Y equals 3 to the cubed root of x plus 4, subtract 1, and then state the domain and range. So initially, like my parent function, I'm just graphing like with the 3. So y equals 3 to the cubed root of x. I know that it would look something like this. It would go through 0, 0. It would go, when x is 1, y would be 3. And then when x was negative 1, y would be negative 3. So it's going to be something like that, roughly. Now I need to apply my 2 translations. So x plus 4 means left 4, down 1. So I'm going to take this graph and I'm going to translate it to the left 4. So 1, 2, 3, 4. So this is my new 0 spot. But then I'm going to move it down 1. So my center point, come on, there it is. This is my starting point. This is what used to be 0, 0, is now negative 4, negative 1. So then again, what did I do? I moved to the right 1, and I moved up 3. So I'm going to still do that. I'm going to move to the right 1, and I'm going to go up 3. Here. So this is going to be right 1, up 3. That's going to put me right here. And then I also have to go down 3 and to the left 1. Going to make it a little bit longer. Negative 3, negative 4, and to the left 1 over here. So my spacing was a little off, but that's going to be my translated function. This is y equals 3 to the cubed root of x plus 4 minus 1. Last part is figure out the domain and range. So again, I use all x values, I use all y values. Domain is all reals, range all reals as well.